Hello GCC, this is our fourth video on intermolecular forces. My name is Dr. Kim. This is for Kim 130, and we have already discussed London forces, dipole-dipole forces, hydrogen bridge forces, and now our fourth force is ion-dipole forces, and we have added this on when we updated the course back in 2017. So what is an ion-dipole force? Well, this is when we have ions in a polar solvent. So we have to have ions, and we have to have something that's polar, meaning it has two poles, dipole. Dipole means two poles, so it's polar. Can you think of a polar solvent? What's something we use as a solvent and we can dissolve ionic compounds in it? If you said water, you're right. So a polar solvent is water. Water is very polar. If you remember, oxygen is attached to two hydrogens, and there's two lone pairs on the oxygen. The oxygen is more electronegative than hydrogen, so it pulls the electrons closer in the bond, making the oxygen a little bit minus, so we have delta minus, meaning a little bit minus, and the hydrogen side is a little bit positive because the electrons are being pulled towards the oxygen, not the hydrogen. So we have two poles, like a magnet, north and south pole, plus and minus pole, two poles, dipole, polar solvent. So, what dissolves in water? What can you think of that's ionic that dissolves in water? Salt. If you said salt, you're right. NaCl can be put into the water, and do you know what it does? It breaks apart into ions. Yeah, we get Na plus, Cl minus, Na plus, Cl minus, and so forth. So now we have ions in water. We're going to have ion-dipole forces going on. So let me show you a little bit more closely how that works. When we have an Na plus ion in the water, Na is a +1 charge, it's positive. So what's going to be attracted to it? The oxygen side or the hydrogen side? What's going to point towards the sodium being positive? You're correct if you said the oxygens. The oxygens are going to point in towards the sodium. So we have attraction between the positive sodium and the little bit minus oxygen. It's a little bit minus, a little bit minus, a little bit minus. So there's an attraction between the plus and the minus here, 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 and here. So I drew 4 waters around my sodium. And so we have 4 attractions there between the plus and the minus. Those attractions are forces, and that keeps the sodium dissolved in the water. And those little water molecules around the sodium prevent it from recombining with the Cl minus to make salt again. And so let's look at what Cl minus has around it. So Cl is -1 charged. So again, what's going to be pointing towards it? The oxygens or the hydrogens? So you're right if you said the hydrogens. So the hydrogens are going to be pointing towards the chlorine. So I'm going to draw some hydrogens pointing in towards the chlorine. All right, and again, hydrogens are a little bit plus, a little bit plus, a little bit plus, a little bit plus. So we have a negative here, attracted to the plus of the hydrogens, attracted here, attracted here, attracted here. So I drew, again, 4 waters surrounding the Cl minus, and the plus minus is an attraction because opposites attract. So that attraction is, of course, a force. Forces are always between pluses and minuses. So we have the Cl minus being attracted to the hydrogens in the water, and that attraction is going to keep the Cl minus in the water dissolved and prevent it from recombining with sodium to make salt again. So basically, this is why salt stays dissolved in water, because you get those water molecules around it. It forms a solvation sphere and prevents them from recombining. So that force again is called ion-dipole force. And now you know the 4 forces that we study in Chem 130 at GCC. Thanks for watching. Good luck.